We take considerable pride in dedicating this picture to America's automotive technicians, to those who have done so much to make our country the world's foremost in the use of the internal combustion engine, and those who make motor muscles toil for man. Less than 50 years ago, the automobile was a rich man's plaything. Can you name these old-timers? But today, 46 millions of automobiles, trucks, and buses, teamed up with more than 3 million farm tractors and off-the-road equipment, make the motor-powered vehicle an important factor in the American way of life, and our citizens are free to come and go as they wish. The United States occupies but 6% of the world's area, has but 6% of the world's population. But free Americans own 78% of its automobiles, 53% of its trucks, 89% of its farm tractors. And they purchase annually more than $2.5 billion worth of replacement parts and accessories to keep them in operating condition. These modern power plants are really tough, and the parts that make up their motor muscles are subjected to tremendous punishment. To meet these destructive factors, all branches of science and engineering are called upon. American ingenuity is the envy of the world. The metallurgist must produce better heat-resisting alloys, and he works in harmony with the chemical engineer, who in turn must produce a better fuel, better oil. The engineer strives for more power with less overall weight. He has created massive diesel power plants which power the diesel railway locomotives, the modern iron horse that pulls the world's finest passenger trains, as well as long freight trains across the continent. The heavy logging equipment that likewise plays such an important role in our economy. Diesels that furnish the muscle that aid giant earth-moving equipment in creating great airports and landing fields in time of war. The power plants that move great armies into the battle areas, and those that power the tanks and prime movers. And the mighty motor muscles of the turbojet aircraft engines that create more than 5,000 pounds thrust in the tails of our jet-fighting planes and interceptors, and give them the power to race through the ether at supersonic speed. Yet all of these masterpieces of science and engineering are of little use without the vast army of repairmen that keep them in operating condition. America has what it takes to work and play in peace. We also have what it takes to work and fight to keep our cherished tradition of freedom. Freedom is everybody's job. Our heavy-duty equipment, coupled with 40 million passenger cars, is a dominating factor in winning a war or winning the peace. The ever-increasing use of the motor vehicle has created a demand for more miles of better highways, and it is equipment such as you see here that gets the job done in record time. These mighty motor muscles make man's task a lighter one and contribute greatly toward our high standard of living. With more than 4 million miles of highways at the motorist's command, The distribution of billions of gallons of fuel and oil is a gigantic problem. American ingenuity solves this by underground transportation through the pipeline, sometimes known as the Big Inch. Here again, man-made motor muscles make this seemingly impossible task an easy one. Here is terrific power. A ton at one bite as it eats its way through the earth, and the mighty diesel engine that furnishes its power purrs along hour after hour, faithfully answering the commands of the operator. The big pipe is now skillfully welded together and inspected. Then, mile after mile, it is carefully lowered to the bottom of the trench. Thousands of miles of pipeline carry crude oil and fuels at express train speeds from the oil fields direct to the refinery, where it is further refined and cracked into various grades of high-grade gasolines, diesel fuel oil, lubricating oils and greases, and then distributed to the thousands upon thousands of service stations throughout the country, which in turn makes possible the universal utility of the internal combustion engine. No country on earth can match American highway transportation. And it is interesting to know that more than 40% of American communities are not reached by rail and must depend solely upon the motor-powered vehicle for the necessities of life. It is no longer a rich man's plaything or even a luxury. It is dependable transportation. It is made dependable by the great army of automotive technicians who keep these motor muscles in prime condition. To aid this army of technicians in securing the proper know-how and correct technical information, Thompson Products has compiled this data into 3 volumes. Volume number 1 for passenger cars. Volume number 2 for trucks, buses, tractors, diesel engines, industrial engines, and many others. Volume number 3, sorely needed data on automatic transmissions for popular cars. All this is yours at no cost from your jobber. Inside of these great engines, the energy of liquid fuel is transformed to useful power. Precisely metered mixtures of fuel and air are compressed, burned, expanded, and exhausted to the atmosphere. This is normally a very smooth purring sound as the hundreds of engine parts go about doing their various tasks. But let a minute leak occur in the exhaust valve, and you immediately have a torch-like reaction, which will cause the valve to first become red and finally reach white heat. Such leaks are often developed from warped valve seats caused by uneven tightness of cylinder head bolts, poorly ground seats, weak valve springs, improper engine timing, and lack of tappet clearance. Valves normally withstand temperatures in the range of 1400 degrees, but 1600 degrees and higher, as reached under leaking conditions, will cause burning. Burned valves, a costly item, can be eliminated with the use of Thompson Aero-type valves, sodium-filled valves, rotocaps, and the constant care and accuracy in the repair procedure. Another type of failure, more expensive than burning, is the broken valve. Here in animation is shown the conditions which bring on metal fatigue, which results in failure, expense, delay, and unsatisfaction. To prevent this, we must point to such things as engine overspeeding, excessive tappet clearance, scaled water jackets, warped valve decks, worn valve guides, worn rocker arms and tappets, as well as weak valve springs. The engine builder, through years of research and experience, has set up specifications for tappet clearance, for spring tension, for maximum speeds to operate. These rules must be obeyed by repairman and operator alike, as the natural laws of science cannot be violated without building up forces which are too strong for even our best valves to endure. Thompson Products, in an effort to reduce this type of loss, have created the Repair and Tune-Up Manual, so repairmen have at their disposal a ready reference for all needed technical specifications. It has also inspired engineers to create new innovations in engines and parts so the engine may have prolonged life. So you are having valve trouble also, and your customer wants an answer, eh? Boy, I'll say he does, and he wants it quick. But it is a tough one to answer, and it's enough to make anyone dizzy. Perhaps there is an answer, and your worries are not too great. I'm quite sure this little lady can be of considerable aid. Hey, wake up and look. Wake up. What's this? Why, it is the new Thompson RotoCap, and I know it will help solve some of those nasty valve problems. And you can get them from your Thompson distributor. He has them in stock. The RotoCap was actually conceived by Thompson engineers prior to World War II and made its first commercial appearance in 1945. It is a simple mechanical device which replaces the conventional spring cap. Here is the spring seating collar and the spring washer, which flexes when pressure is applied to it. These are the nest of spiral springs and balls which fit into the retainer cap. And here the same nest of parts are shown assembled. Now a cross-sectional view of all of the parts with the valve spring and tappets in their respective positions. Note the position of the spring washer. Rotation prevents prolonged exposure of any one sector of the valve to a local hot spot on the seat. It imparts a light wiping action between the valve face and seat, preventing deposit buildup. Stem deposits are prevented from forming at the top of the guide. Keep your eye on the flexing washer as the valve opens and closes. This movement provides the motion for positive valve rotation. By this action, the valve is caused to rotate approximately 6 degrees with each opening and closing of the valve. Notice how the flexing washer forces the ball down the incline, compressing the small spring. As the ball rolls downhill, a rotating motion takes place. The small spring then returns the ball, and we're ready for a new cycle. These actions combined make it possible to extend valve life from 2 to 5 times. Here is a close-up of a page in the Thompson Repair and Tune-Up Manual giving complete information and instructions concerning the installation and replacement of roto caps in a Mack truck engine. This close-up shows in detail how the roto cap is installed in Chevrolet truck engines to give increased valve life and performance. Varying temperatures in valve operation often cause distorted seats and valve faces. The use of the interference angle in valve reconditioning will relieve this danger considerably. Grinding the valve face 45 degrees and the seat 1/2 to 1 1/2 degrees differently allows the valve to ride the top of the seat with a hairline contact. Under actual operating conditions, these two surfaces become mated and provide a more perfect seal against power loss when the engine is at operating temperature. Valve grinding techniques are the same as those used in normal valve reconditioning. Here, the valve face is ground to the standard angularity, which in this case is 45 degrees. The fixture for dressing the seat grinding stone is now adjusted for the interference angle. The gauge is set to 45 degrees. Then add one more, which makes 46, and provides for the difference in angularity. The stone is now dressed to 46 degrees. Then the valve seat is generated. In some cases, you will find it necessary to use the 15-degree and 75-degree stones to bring the seat to its proper position and width. Here is a set of small hole gauges that have proven very effective in finding guide wear, particularly at the top and bottom openings. A go and no-go gauge or a pilot may pass this guide as usable. Be safe. Use good gauges. Here is a display of the latest in sodium-filled valves. They provide mighty motor muscle for our heavy-duty equipment. Years of engineering and scientific research have proven that best performance is obtained by carefully controlling the amount of heat to be conducted to the valve stem or guide area. This is accomplished by controlling the length of the stem cavity. The short cavity is used where only moderate cooling is desired, while the long cavity is used on the more severe applications where the guide is well cooled by the water jacket. A step cavity is also used. It provides extra metal and strength under the head, as well as metering the amount of heat going to the stem. Sodium valves are thus tailored to each individual engine requirement. An aircraft valve is shown for comparison purposes. It displays the reduced cavity under the head, as well as a layer of heat-resisting metal covering the entire head. These latest developments are used by our Air Force bombers, our fighters, and our transport airlines. Thompson Products takes considerable pride in making this contribution to the defense of our country, as well as aiding our great fleets of truck transports in keeping their equipment rolling. Heavy-duty equipment such as these big fellows really make molehills of mountains. And to keep them on the job day after day, rain or shine, winter and summer, is of prime importance to their owners. They must be carefully groomed by their mechanics, and their muscles of metal must be made of the finest alloys the metallurgist can create. We at Thompson's are rather proud of the part we have played in the development and engineering of newer and better materials that have contributed so much in providing these mighty power plants with greater efficiency and longer life. Whenever or wherever a huge earth-moving job is required, diesel-powered units like these get on the job and get it done quickly. We would like to call your attention to the latest in diesel injector testing equipment. This new equipment checks injectors of more than 300 models of diesel engines. A special jig is placed in the vise to hold this GMC diesel injector. It must be completely disassembled. Note the many small parts that make up its anatomy and the care which is used in taking this unit apart. These small parts are precision machines, and they must be handled with extreme care. As the various parts are dismantled, they're placed in pans containing a cleaning solution. All parts are carefully cleaned, then inspected, and the injector is reassembled. The injector is placed in this fixture and tested for spray patterns. The injector is now given the popping and pressure test. It must hold 1,400 pounds per square inch for a period of 1 minute. On this side of the fixture, a Cummins diesel injector is being tested for back pressure and capacity. Equipment such as this aids the operator in keeping his units on the job. Complete technical information on diesel injectors can be found in your Thompson Repair and Tune-Up Manual. Practically all heavy-duty equipment at some time or other is subjected to lugging. By lugging, we mean pulling in too high a gear ratio. This causes pistons to overheat. In diesels, lugging may lead to stuck rings. Even in normal operation, diesel piston rings and lands are subjected to high pressures. Likewise, the additional effects of lugging often break both rings and lands. In gasoline engines, the detonation which accompanies lugging also breaks both rings and lands. The abnormal heat generated with detonation causes expansion beyond the allowed clearances, and thus scoring is inevitable. This can be eliminated by keeping the spark properly timed, by using the proper fuel, and by no means allow the engine to lug. The broken lands can also be repairman-made. Any engine that has run will develop a ridge above the top ring travel. Where new rings are installed without reboring the block, it is absolutely essential to remove the ridge. Not all piston troubles are at high speed and heavy loads. The milkman and baker with their stop-and-go delivery service have some problems too. The engine does not warm up in stop-and-go service in the colder climates. As a result, the exhaust gases tend to condense in the cylinder chamber and form acids which corrode the pistons. Frequent oil changes and the use of winter covers will reduce this hazard. The Thompson steel-belted piston is a new matured design, having proven itself under all severe operating conditions. The steel belt incorporated in the piston skirt is the key to controlling expansion. A heavy rib in the head provides physical strength and the path for heat to flow to the skirt area. To illustrate how it operates, we show it exaggerated in animation. A continuous steel belt is cast in the piston skirt. This belt is graphite coated so there is no adhesion between the steel and aluminum. Likewise, as the piston temperature rises, the aluminum, in expanding, will follow the contour of the band, greatly reducing its diametrical expansion. The rib of metal in the head section serves two purposes, by providing brute strength and a path for heat flow to the skirt area, where it is finally dissipated to the water jacket. The rib, positioned in line with the pin bosses, directs the expansion in line with the piston pin. Belted pistons are finished in the oval shape by cam grinding, which allows extra clearance on the pin boss sides and a quiet running fit on the thrust faces. As the engine comes up to a hot running temperature, this controlled expansion carries the pin bosses out to the cam clearance area, but maintains the normal running clearance at the thrust faces, thus eliminating all tendencies to score. Now, let's restore the energy in this big baby. Wow, look at the size of that piston and cylinder sleeve. You know, the majority of Thompson distributors have well-manned and well-equipped machine shops. Most of them are prepared to rebuild all types and sizes of automotive power plants, from the smallest passenger car engine to the larger stationary power units, such as seen here. Worn out, perhaps from overwork, but after a clean bath and expert mechanical operations, this baby will soon be back on the job. The cylinder block is placed in this up-to-date cleaner, where it will be thoroughly cleaned inside and out to remove all traces of carbon and dirt in water passages and oil leads. This will require about 1 hour. Careful attention to this detail will pay dividends in engine efficiency. Note how clean these bearing caps and saddles are. This makes for more accuracy in final assembly. The block is now ready for further processing. Cylinder heads must be cleaned too. In this case, the head is sandblasted to remove all traces of carbon. Compare the two clean combustion chambers with the dirty ones on your left. And here is the thoroughly cleaned cylinder head, ready for rebuilding into a useful unit that will give increased valve life as well as better performance. Your Thompson jobber has expert valve reconditioning service and takes considerable pride in his equipment and careful workmanship. Regardless of size, accuracy is the major requisite. Next, the crankshaft must be made ready. Again, sandblasting does a thorough job and is becoming quite popular. Many Thompson distributors are providing MagnaFlux service in checking crankshafts for checks, cracks, or fractures. This machine is quite costly, but it reduces the chances of crankshaft failure in the field. A lower-priced but equally effective system of checking crankshafts for fractures and cracks is the die check system. Regardless of which is used, it is a safety factor that is well worth the extra cost. After checking the shaft for defects in its main bearing journals and rod bearings are precision ground and highly polished to very close tolerances. Care exercised here likewise aids in the development of more powerful motor muscles. For extreme accuracy, the main bearings are line bored to provide perfect alignment with exacting clearances. Careful crankshaft fitting is of prime importance. Tension or torque wrenches must be used in final assembly so as not to disturb these delicate tolerances. Here are the Thompson CL77 bearings precision-made to accurately fit the engine block and with clearance allowed for the newly ground shaft. From appearance, we call it the ugly duckling, but it was not made for beauty. It was made to be and is the best bearing material known today. It consists of a steel back, a layer of copper lead, and finally, 1/1000 of tin lead plate. The tin lead plate provides low friction, long wearing surfaces, while the copper lead provides the stamina to withstand the pounding forces. Yes, more problems for the service manager. This time, a fuel pump. But our lovely lady has the answer with the new Whirlajet pump, a new product created by Thompson to solve the service manager's problem. It has incorporated a feature for adjusting the fuel delivery pressure. So easy the little lady can do it. This new pump, called the Whirlajet, is electric motor driven and is compact in design. Mounting brackets are provided on two sides so right-hand and left-hand installation can be made with ease. A sectional view shows the respective positions of the various parts. The check valve, which keeps the pump primed, the pump body, and the fuel outlet. The Whirlajet impeller is simple in design without close running fits or wearing parts. Within this pressure control valve, provisions are made to bypass fuel when the fuel demand is below the maximum output. This is truly a new pump, compact in design with provisions for mounting on all types of equipment. Ample pumping capacity to handle both the smallest to the largest engines. For your next fuel pumping problem on trucks, buses, boats, tractors, or passenger cars, either 6 or 12 volt, consult your Thompson distributor. A new sleeve has also come into existence. It is the Branberry sleeve and was born during the last war in an attempt to eliminate scoring during the break-in period on new engines. This section shows the inside surface. It is cut with V-shaped grooves, 4/1000 inch deep, spaced at 40 to the inch, giving it a diamond-shaped pattern. The grooves are filled with a special plastic graphite material, then cured in an oven, which makes a tenacious bond between the graphite and cylinder material. The finished sleeve has a dull black appearance. Here is one which has endured 204,000 miles of heavy-duty service. The cross-hatch marks are still visible, meaning the wear is less than 4/1000 on a side. Hundreds of engines are in use, showing these truly remarkable results. The modern way of making such installations is to prepare the holes, then freeze the sleeve to shrink its diameter, and then slip them into place with only slight pressure of the hands. Now let us visit the famous Daytona Beach measured mile. Today is the last day for qualifying for positions in the National Stock Car Race, which will be held here tomorrow. Competing cars in this race are stock in every sense of the word, the same as you and I drive on the highway. Of course, they've been tuned to perfection to get all the power and speed that is possible. The cars have a 2-mile running start before they run through the measured mile. Many of these cars were clocked at well over 100 miles per hour. The timer is informed that a hot rod is coming through. And here he comes in his hopped-up Model A. And me and that Mercury were neck and neck. Call a cop. This specially built car is the holder of several speed records. It is right on the ground, and its ultra-streamlined body is loaded with motor muscle. It is being pushed to the starting line in an attempt to set a new world record on the beach. But ill luck shared the driver's seat, and here is all that is left of a thing of beauty but a few minutes ago. The last car has qualified, and tomorrow one of these cars will be a winner. Here comes the parade of nearly 100 stock cars that have qualified for today's 160-mile grind. These cars will take terrific punishment, and you will soon learn the reason your American car is the best in the world. Look at them come into this first turn. Take it easy there. There's not enough room in here for all you guys. Tough luck, buddy. Ooh. Yes, sir, me and that Mercury are neck and neck. Hey, don't break up that car. Wrong way, mister. That's it. Ride him, cowboy. Here comes the winner, and those man-made motor muscles have served him well today. The same punishment can be given to wheels in the testing laboratory. Here is such a test in process. Note the bumping action as we turn to a worm's eye view. The upper and lower control arms and all moving parts take terrific shocks under the baptism of dust, sand, rain, snow, and all elements of the weather. The threaded joints, as illustrated, are fitted with 15 to 20 thousandths clearance between the threads to eliminate any chance of bind as the car goes through the many distortions required on the highway. To ensure free movement in all type of weather, lubrication is also of prime importance. With a threaded bearing in the presence of normal road sludge, it is impossible to supply lubrication without a working clearance. Here we show a proper threaded joint as used by original equipment and supplied by your Thompson jobber. With ease, the grease flows to the threads, and there is no danger of binding from road deflections. All this means miles of safe driving for your family and loved ones. In the normal use of an automobile, there are actually only two main actions which take place in the tie rod end. One takes place going over bumps and irregularities in the highway, and the other takes place when turning to change the course of travel. This may be more clearly explained by animation. The irregularities of the highway cause an angular movement between the ball stud and the tie rod. But in steering to change the course of travel, a twisting action takes place between the ball stud and tie rod. When this action takes place on a single bearing, wear takes place at a rapid rate. Here is an example of the wear normally found in the plain tie rod design. It causes uneven steering and is a hazard to the driver, as well as all motorists on the highway. Actually, there is no need for taking chances, since with modern tie rod ends, this hazard of wear has been eliminated. Here before you is the Thompson dual bearing tie rod, where two bearings are provided. one to handle the irregularities of the highway, and a second for steering. Let us look at this motion once more. As the wheel goes over road irregularities, the angular motion between the ball stud and tie rod takes place at the outer bearing. As we go back to the turning movement, which gives the twisting action between the ball stud and tie rod, we expose a new bearing surface to the elements of wear. Note how one movement takes place on the outer surface of the ball stud, while the steering motion is confined to the inner surface. Here is a box of Thompson tie rod ends, made with the dual bearing principle available from your Thompson distributor. When in need of tie rods, why not ask for Thompson dual bearing? Here is our latest in technical know-how, the automatic transmission manual that tells you what you want to know about the maintenance and repair of automatic hydraulic transmissions. As more and more cars leave their factories with these units, this manual becomes a priceless source of information. Yes, sir, we are extremely proud to present to the automotive trade through our Thompson distributors a complete valve service, including valve rotation and component parts, pistons, pins, and cylinder sleeves, a complete con rod and main bearing service, dual bearing tie rods, an independent wheel suspension service, spring bolts, shackles, and Harris bushings, water pumps and electric motor-driven fuel pumps, all of which are used as original equipment. Get it from your jobber. He is on your team always. His machine shop is at your command. He planned it that way. To serve you better, he has gone to considerable expense in equipment and personnel in order to provide precision service to aid you in making more profit. And these mighty motor muscles will continue to aid in keeping our traditions of freedom and maintaining our position as the greatest nation on earth.